Hello everybody, I'm Gloria Beraldo, a researcher in the National Research Council of Italy, CNR-ISTC, and I'm going to present our work related to the Spoke 10. Part of this work is also made in collaboration with University of Padua and Lincoln. Inside the Spoke 10, we are interested in creating value-inspired AI driven systems that emulate the human capability of extracting information from the context, represent them in a symbolic form, and continuously learn by observing the effect of the action. So we are focusing on emulating this capability on a service robot like TIAGo that can manipulate objects, navigate, and interact with humans. So you can see that these tasks are very time-consuming and challenging, especially in a social environment populated by people that can dynamically impact on the robot decision-making process. So with this purpose, I'm exploring two different knowledge representation methods. First, a grounded probabilistic PPDDL based on the learn context-aware symbol for the next robot action planning. And the second is a causal model generated on the fly to study cause-and-effect relation and facilitate the prediction of the human behavior. By focusing on the first, our contribution consists of proposing a new framework inside the ROS to merge option learning and symbolic reasoning. We extend this classical data architecture that allows the robot to autonomously sense plan act in the social environment with the addition of an abstraction process that classifies the contextual environment state, acquire the beginning and the end of the execution of the robot action, and create an enriched symbolic probabilistic PDDL based on the success and the failure the robot encountered. This representation is very useful for the next planning, since the robot will learn which are the preconditions and effect of its action. We observe the system inside a dynamic and realistic simulation affected by uncertainty, and with respect to the literature, no oracle of fixed behavior are used. The data collection are made in autonomy by the robot based on its noise perception, and the robot interaction with the environment also changes due to the presence of a person or an obstacle that may prevent for reaching his high-level goal. In our case, carry an object from a room to the second one. The result demonstrates that the new information is successfully acquired from the robot experience and represented in this PPDDL. For instance, to give an intuition, let's consider this example, pass through the door with success. So, as you can see here, it is necessary that the symbol 137 and the symbol 134 are true. And as is graphically represented, means that the robot should be at the peak object position and hold the object in its gripper, as we expect. As regards the second work, the novelty aspect instead is to perform the causal analysis based on the bird data collection on the fly. In fact, the available methods in the literature are not able to run directly on the robot and to exploit the causal model in real time. So, with this purpose, we have designed and released a new ROS framework called ROS Causal that is totally open source. So, if you are interested, please scan this QR. We evaluated the framework in a human-robot spatial interaction scenario with a different 50 people where the person and the robot can cross together. And the result causal model were consistent both in simulation and in real robot experiment. In addition, we assessed the accuracy of the achieved causal model as the sampling rate and the number of input sample change, as you can see here reported in the graph. And we found that in our scenario, just with 40% of the whole total data, recording at 10 Hz, was fine for generating a reliable causal model. So to conclude, we have examined the potential advantages of describing the robot experience via context-based representation that are consistently learned by the robot from a few samples. So this sort of social training can be very effective for long-term robot autonomy in dynamic and uncertain environment. Future works will be focused on extending the proposed framework with more human-like representation in order to improve the communication with humans about the acquired knowledge. Thank you for watching.